Okay, peeps, for this video, I'm going to do the problems on page 13 in the packet, the types of chemical reactions. Notice this one says 6 instead, and we keep talking about 5. It's because we're not adding acid-base reactions yet. So ignore that. We're going to stick with our 5. Acid-base reactions is the 6th. If you recall from the last video, I went through this little card and the types of reactions. I just want to review it real quick that we talked about. The five types of reactions. The first one's a synthesis, where A and B combine together to make AB. So something like this example, where iron and oxygen are combining together to make iron oxide. Ignore all the numbers. You're just interested in the elements. Element A here and element B here. So iron and oxygen, and then they bond together to make something. So that's a synthesis. Decomposition is the exact opposite, where instead of making something, you're breaking something, you're decomposing it. So in this example, you're taking water and you're breaking it down into its 2 parts, hydrogen and oxygen. The next 2 types are single replacement and double replacement. Single replacement is, I like to pay attention to the A metal and the B metal. So in a single replacement, one of the metals, in this case sodium, is all by itself, and after the reaction occurs and you see the products on this side, now the B metal is all by itself. So in other words, the sodium came in and kicked this potassium out, and now the potassium's all by itself. And double replacement is very similar, except there's just another element involved. So in this example, again, if you pay attention to the metals. So at first, and so notice I don't have sodium alone this time. Before, for single replacement, sodium was alone. Now I have sodium bonded to something. So sodium is bonded to oxygen and potassium is bonded to chlorine, and they switch places. They displace each other, or replace each other. So the sodium and the potassium just switch places. Instead of sodium being with oxygen, sodium's now with chlorine, and the potassium's with the oxygen. So that's a double replacement. And then the last one is the combustion reaction, where you're one of the things on this side of the equation. Remember, this side of the equation are the reactants. When one of the reactants is oxygen, you could technically say you have a combustion. So that's the 5 types of reactions that we're going to talk about. Okay, let me go through the answers on page 13. So first, I'm gonna first just look to see if I have something. Well, actually, let's just go through them. This is kind of big and complicated, and remember, a big complicated one is often a double replacement, and this is a double replacement. If you look, the sodium metal here is going to kick out the calcium, and they're going to switch places. This one wants you to balance the reaction also, which we could do. If you look on this side, I have 2 bromines on this side, but only 1 on that side. So if I put a 2 here, then my bromines will be balanced. That just unbalanced my sodiums. I had 1 and 1. So if I have 2 now, I have to put a 2 over here. And look what that just did to my OHs. It just gave me 2 OHs, which is what I need. So that's balanced. This next one, again, let's look at the arrow. If you look on this side of the arrow, on the product side, there's only 1 product. When you have only 1 product, that means you're making only one thing. So that's a synthesis. These two things, see the plus sign? These two things came together to make just one thing. So that's a synthesis reaction. To balance it, it just needs a 2 over here to give you 2, because this would be 2 nitrogens, and this is already 2 nitrogens. And the hydrogens are a little bit more complicated. This is 2 times 3, so this is 6. This is 2, and the hydrogens on this side is 2 times 4 is 8. So there's 8 hydrogens and 8 on this side. And then the sulfate, and sulfate. This next reaction, look what we got there. One of the reactants is oxygen. When one of your reactions is oxygen, it's a combustion. This one is very difficult to balance because of this single oxygen here, and that a 9. The temptation is to put a 9 here to have 18 hydrogens on both sides, but you'll end up with an odd number of oxygens. And to balance this actually ends up balancing this way. I'm not going to go through it, but if you check these numbers, it'll work. Let's see, number 4. Number 4 is a single replacement. See how lead is here all by itself? But the lead is going to come in and kick out that hydrogen, and the hydrogen's going to be alone. And the lead's going to bond with the phosphate. Right now, the hydrogens, at the start of the reaction, the hydrogen's with phosphate. But at the end of the reaction, the lead is with the phosphate. So this is a single replacement. To balance it, you could start with the leads right there. Actually, let's end with the leads. Hang on a sec. There's 2. This whole thing is called a phosphate. There's 2 of them. So if we put a 2 here, that gives us 6 hydrogens, and I can get 6 hydrogens here, and then the lead, I can just put a 3 there. All right, the next one. Remember what I said, the bigger and uglier they look, they often are a double replacement. And so let's look to see is it a double replacement. Here's the positive ion lithium, here's the positive ion ammonium, and they switch places. Lithium's with nitrogen right now, but then lithium's going to switch, and lithium's going to go and bond with the nitrate. Right, you can see here's the nitrate, and here's the nitrate. It's switched. And here's the lithium, and here's the ammonium. They switched who they were bonded with. So this is a double replacement. And to balance this, there's 3 lithiums on this side, so you need 3 on this side, and that gives you 3 nitrates. So you'll need a 3 here for 3 nitrates. And that NH4, you just got 3 of them also, but you need 3 of them. So that's all you need to balance that. And then number 6. Number 6 is also a double replacement. It's a little bit less clear because of how this water gets made, but if you look, you have the hydrogen and the aluminum. They're going to switch who they're bonded with. The hydrogen's bonded with the bromine, but they're going to switch, and the aluminum's going to bond with the bromine. And instead of the aluminum being bonded with with the oxygen, the hydrogen's going to bond with the oxygen. To balance this one, if you look, again, we could start with the bromines. There's 3 bromines there, so if you put a coefficient of 3 here, you'll have 3 bromines. And if you look to see what that does to your hydrogens, that gives you 3 hydrogens right there. You already have 3 here, so you have 6 on this side. So to get 6 on the product side, you'd need a 3 there, and that would give you, because that would be 2 times 3, it would be 6. And look at the oxygens. Oxygens are 3, and oxygens are already 3 over here, so that balances it. The rest of this you do not have to do. All right, so that's it, peeps.